Hi everybody, welcome back to my channel on Feynman integration. Today we'll be doing this integral using Feynman integration and also this fact, which I've proved several times on the channel and utilized several times on the channel, that the integral from 0 to infinity of the sine of tx over x dx is equal to pi over 2 for all t not equal to 0. Sorry for that. Anyway, yeah, here we go. So we'll do something a little bit different in this evaluation. We are going to be reparameterizing it in terms to make a function of t, but we're going to be inserting a t two different places. So our function of t will be equal to the integral from 0 to infinity of tx minus sine tx over x cubed dx. Okay, so now what we're going to do right away is we're just going to take two derivatives real quick. It should be pretty easy. So what we'll get is f prime of t is equal to the integral from 0 to infinity of the derivative of this part. It's all going to be over x cubed because with respect to t, x cubed is a constant. So I'll just go ahead and put that there. The derivative of tx with respect to t is just x. Then we'll get, we'll get minus the derivative of this thing with respect to t, which will be it's going to be x cosine tx. And all that is integrated from 0 to infinity dx. All right, so now you notice that this will go away, this will change to a 1, and this cube will become a squared. So there's our f prime of t. All right, one more derivative. F double prime of t is equal to the integral from 0 to infinity of, well, now this entire first part's going to drop out because it's a constant with respect to t. So we only need to take the derivative of this, well, with the negative. So let's see, that's going to give us the integral from 0 to infinity. Well, the derivative of cosine of some function is equal to negative sine. So we'll get positive sine tx times the derivative with respect to t of tx, which is x over x squared dx, and of course that cancels. So now we're left with this, which, as I stated earlier in the video, is equal to pi over 2 for all values of t not equal to 0. Okay. So, all right, let's go back to f prime of t by integrating f double prime of t and also integrating this with respect to t. So just going backwards, we get that f prime of t is now also equal to the antiderivative of this with respect to t. So that would be pi t over 2 plus c, of course. We need to get rid of that c. So how do we do that? Well, we know that if we plug in 0 for t in our f prime of t written this way, we're going to get 0 because 1 minus the cosine of 0 is just 1 minus 1, which is 0 over x squared is still 0, and the integral of 0 is 0. So that means we know that 0 is equal to pi times 0 over 2 plus c. In other words, c is equal to 0, so we don't need it anymore. That's just f prime of t. All right, well, let's get back to f of t so we can plug in 2 to get our answer. All right, so f of t is going to equal the antiderivative of this with respect to t, which is going to be pi t squared over 4 plus c again. Okay, so now let's get rid of this c. By plugging in 0 for t, we will get 0 minus 0, or just 0. So if we plug in 0 for t, we get that 0 is equal to 0 plus c again. the c drops out. And we're left with f of t being equal to this. And if we plug in 2 for t, we will get our original integral back. So let's do that. All right, if we plug in 2 for t, we'll just get 2 squared, which is 4, which will cancel with that 4 in the denominator. So this is equal to pi. There you go. That's it. Hope you enjoyed that.